Hello, everybody, and welcome to today's webinar. This webinar is brought to you courtesy of LiLyVille Educational Consultancy, which is an educational consultancy that I founded in 2019. Yes, I'm trying to remember the exact year. Basically, it was birthed out of a passion to help young people make informed decisions about their careers and professional development. And this is one of it, because machine learning is one of the it's not like it's not been here for all this while, but it's become more prominent, especially with the rise in AI and everything that's been going on. So, yes, and our goal is to help people make informed career decisions. And with 21st century careers, you don't have to have only one sort of career. You can have different transitions and also you're not restricted to, okay, this is what I studied, this is what I'm going to do for the rest of my life. The 21st century just gives us that opportunity to evolve in many different ways. So machine learning is applicable across many sectors, which you'll find out. I'm not the one giving the talk, so just going to keep quiet about that. I am Lydia, founder of LiLyVille Educational Consultancy. I studied medical engineering for my first and second degrees, and I'm doing a PhD currently in biomedical engineering. So if you want to reach out to LiLyVille, this is our email, lilyvilleeduconsult@gmail.com. Please send an email if you've got inquiries or if you know somebody that would want to do something like this. And please follow us on social media. We've got a website. We're on YouTube, LinkedIn, Twitter, Instagram, Twitter X, that's what it's called now, Instagram. So please follow our page. And lastly, how did this come about? So I don't know if she's on, but Prosperity, shout out to Prosperity, who is one of my mentees. So there are plans that she has for the summer. And I was just like, okay, can you give us the link of the summer school that you were considering? And so that we can post it on LiLyVille just to give people access to these opportunities. And she was just like, oh, actually, she can curate a list of several machine learning summer schools across the world. And that's what she did. She provided us 22 links on machine learning, I think deep learning and artificial intelligence in different parts of the world, summer, winter, and autumn schools. And this is like a video from the Instagram page. So all those have been posted from the 1st of July, I think, to maybe the 21st of July. So different links. So I told you I've seen Dina's slide. There's a roadmap for getting into machine learning in like a certain period, and this is something that you could target if you go and look at the links. You could target the ones for next year just to consolidate your learning. There are some funding that are available for some, and some are not funded, but yeah, just for you to know. So that's how this came about. And I reached out to Dina, and she was so gracious to accept. So we're super, super honored for her to be on this. And some of you wonder why I call her Dina. You know how when you grow up with people, there's always a house name that you know them more than their official name. That is why our parents, our fathers, met over 65 years ago as young people in primary school, and they were best friends. And we thank God for the legacy of their friendship and their relationship, because it transcended across the whole family. And here we are, by the mercies of God, like impacting the next generation. So yes, one thing I'll tell you is that also cherish relationships, because that is vital also in both your personal and professional lives. So that is it. This is one of the awards that Dina won. Like, she has plenty awards for every single educational qualification and all that she has. And I think I've sent it to all of you. It was a struggle to get her to put that in out there, but we thank God. We thank God. So without much further ado, I'm going to hand over to Dina right now. And at the end, I'm going to flash this QR code and also this, just so that you can give us feedback on today.
Thank you so much, Lydia. Thank you very much, everyone, for being here today. It is really such an honor to be here to just share some learnings about machine learning. And I'm really grateful for the opportunity Lydia has provided me and all of us. I pray that God will continue to bless your work, your impact, and your labor of love. And yeah, to everyone here, thank you for taking the time out to be here. So I'm just going to share my screen. So yes, today we're going to be talking about getting into machine learning. I'm just going to be sharing a kind of roadmap, sharing my experience as well, and hopefully giving you pointers for your next steps. So Lydia has done a very good introduction, so I wouldn't bore you much about myself. But my name is Zainab Titus, and currently I'm a machine learning engineer. I have a background in petroleum engineering to start with, but then, like some of you here, I transitioned, and so I think it's just good for me as well to let you know that I didn't start machine learning, like way back, or I didn't start coding from the age of 5. Apparently, um, if you can see my slides, so my journey into machine learning started at some point just before I started my PhD. So basically, I was exposed to basic programming during my undergraduate and my master's. But then it wasn't until 2 months before I started my PhD that I actually started programming in Python, which is what, I use at the moment for machine learning and what most machine learning engineers use. At a basic level, I was exposed to programming in QBasic. I did a bit of programming in MATLAB, but I wouldn't say I was a proficient programmer. I found my way around solving my problems, but it was not like a daily habit to program. So in my first year in my PhD, I took a machine learning course just online. Like some of you might have seen, there are many machine learning courses online. Um, it's one that's very popular if you've heard of Andrew Ng. At some point in the slide, I'm going to share a few references or courses as well. So I took a few months to take the course, and then towards the end of my PhD, I did an internship as a data scientist. And I think for me, it was just really born out of the passion to translate what I was learning to real world use. I felt that was one of the best ways to actually establish my learnings, to solidify the teachings. So rather than just take tutorials or read or even do mini projects, I wanted to see how machine learning was applied in the real world. So those were two steps I took in the first year of my PhD. And then by year 2, I started applying machine learning to my research. So I took the first year to just learn and just build up myself. And then by the second year, I started applying it to my research. I just started adapting what I had learned to solve my own problems in my studies. And I also started teaching machine learning modules. So I started assisting lecturers to teach on machine learning modules in my department. And really, it was because of two things, I would say. First, I loved teaching, and every opportunity to teach would, draw my attention. And so the opportunity came up, and I thought, why not? But secondly, one of the best ways to solidify your learnings really is to teach other people. So teaching forces you to actually ensure that you learn, not just learn to pass, but also learn so that you can communicate better and you can also help other people understand the concepts that you are teaching them. So I started teaching machine learning models in my year 2. So those were two steps I took the following year. And then somewhere 2 years later, thereabout, I now started working as a machine learning engineer in a geoscience company. If you're not familiar with geoscience, it's just really about earth science. So it could be anything. It could be weather forecasting. It could be, mineral extraction or, drilling, just different aspects of, studying the earth. So I was working and I was building solutions, machine learning solutions for the industry. So it was really very practical, result-oriented for me, and it was a good opportunity for me to put to use, my years of research in this field. And today I'm at a point where I am relearning and upskilling. It's important that sometimes you take a step back, you assess, you relearn. I'm going back to my engineering math textbooks and reading them again. Sometimes people are like, why are you doing that? But then, there are times when you find that when you step away, and you come back to your endeavors, sometimes you look at things with a fresh perspective and you can explore things better. So I'm actually taking a step back to, upskill myself. And it's also because the field is progressing really rapidly. Within a year, within 2 years, the roles of a machine learning engineer will change. Certain skills will be added onto it. And so if you don't upskill, if you don't keep learning, you find that you are obsolete. You're not so relevant in the field after some years. So this is where I'm at the moment. I think for me, a few things I just want to highlight. And the first thing is I want to just show you three key things about my journey, which are my three core transitions. And the first one is I didn't just stop at reading or taking tutorials. I wanted to apply my coursework or the tutorials, the courses I had learned, I wanted to apply them to real world use. So right on in my first year, I did an internship. I was taking a machine learning course, and when I felt I was comfortable enough, I went on to build on that and have some sort of practical experience. So those are things that, speak and go a long way for you, if you're intending on pursuing this career, because a lot of times, you want to show people what you've built, projects you've worked on, and not just that you can speak the language. People want to see real world impact that you have to show for it. And you never know really how far you can go because one of my first projects really is, it to me is very close to my heart because it's the first one, but also, it launched me into the industry as well. So, yeah, take a step and further your learnings and put them into practical use. The second key part of my transition is where I went from just being a learner to being a teacher. So in my second year of PhD, I started teaching machine learning modules. And to be honest, it's not like I was an expert by that time. It was just a year after I'd started learning a lot of things about machine learning. But I think what that did for me is it pushed me to know more. Sometimes I would offer to teach on models that I'm not very familiar with because then I would work more, I would do more research, I would learn more, try to do more practical, learn, and then I can, teach other people to solidify my learnings. So that was also a key step of my transition that I wanted to highlight because I think it's important to find ways of solidifying your learning. And the third part of my transition I want to highlight is where I went from just doing research to actually working in the industry. So I had done research in machine learning, I had applied it to, different things, different aspects of my course, of my studies, my program. But then I felt like I could translate this also to industry use. I mean, obviously, I'm not saying you have to be in the industry to make your impact. I love the academia and probably at some point I'll be back again. But I think what I'm just trying to say is, um, instead of just, doing theoretical work, sometimes, you can not sometimes, it's important for your theoretical work to be practical as well, so that, it can make a difference. You can at least yeah, know that your work is getting some results and you're not just, learning and researching, and there's no avenue for you to apply what you have learned. So really, this is my journey into machine learning, and I just wanted to highlight this to show you that I didn't start machine learning, when I was, even in my undergraduate, but it's been a journey of learning. It's been a journey of thinking about how I want my path to go. It's been a journey of hard work. There's been, a lot of times when I would think that it's probably way out of, my own background or sort of where I'm coming from. But I think the world today is your oyster. There's so many opportunities, and it depends on, what you want to pursue. So with this little, will I say, highlight of my journey, I want us to get into today's talk. So for today, we're going to be looking at a number of things. First of all, I would just want to talk to you about why, machine learning is important. Why are we hearing all the buzz about artificial intelligence? And then what are all those things? I'm just going to say it in plain English. I'm not going to try to, talk about mathematical formulas or derivations or what. No, it's just, the simplest way we can understand it, right? And then we'll look at some career paths and some of the skills that you need to actually be a machine learning engineer who would be working, in the industry or even, running your own, business or doing your own projects as a machine learning engineer. And then I'll highlight a roadmap with a few resources and how you can work on projects that would really stand out and how you can, just showcase your learnings and what are ways you can get experience in case you want to venture into the industry. And we'll just talk a little bit about ethics. That's because it's very important in this industry. We don't want our data being used to, train models that are not safe or that are not responsible. And then I'll just leave you to kind of, draw out an action plan if you want to take your next steps. And then if you have any questions, we'll talk about them. So yeah, let's get right into it. So why does machine learning matter now? Why even now? So two words, accessibility and opportunity. And just to buttress that, we can see a very interesting image here on the screen, which talks about the revolution we're, undergoing as, as a people, as the human race today, really. In the past, there have been different revolutions that humanity has experienced. We've had this industrial revolution where, the steam engines were really at the forefront. We started really moving around without using animals. We could get on trains. We could go, from one city to another, one country to another. So really, the first industrial revolution was driven mainly by the steam engines. And then we went to the advent of electricity, where electricity, changed a lot of things for us. Personally, if I were to think of one key scientific discovery that has changed the face of humanity the most, or the most important one to me, in my opinion, is really electricity, because to be honest, that's the foundation of digitization, computing, and a lot of things. So yeah, we had the industrial revolution of electricity. And then we went into computing, Charles Babbage and all of that. They, helped to develop computers, and we saw the internet evolve as well, and that brought about a rapid change in advancement in civilization. But today we're experiencing another kind of revolution, and that's the age of artificial intelligence. So I'm gonna talk a bit about, what's the difference between artificial intelligence, machine learning, data science. Those are words people throw around, and maybe you're not very familiar with them. We'll talk about them. But basically, what is happening today is we're seeing how, intelligent machines are changing the way the world operates, and that means, we also have to adapt to the way we do a lot of things. The way we learn is changing. I mean, look at us here. We are learning, remotely. So, I mean, yeah, things are changing, right? And at the same time, if you think about it, some of the jobs that were available during the first industrial revolution, they're no longer here. So jobs will change. It doesn't necessarily mean AI will take over our jobs. It means that we'll have to adjust, right? Things will change. We have to change our direction. We have to, like learn different things as well. And we have to be more innovative and creative. So basically, machine learning is important because of where we are today. You know, we are undergoing a industrial revolution where artificial intelligence and, basically machine learning, data, and a lot of will I say systems around that kind of artificial intelligence are changing the way the world operates. So basically, what are the things also that are really pushing this movement? So there are a few things that are helping to advance, the revolution of intelligence. And the first thing is we have more computational resources, we have more computing resources and data. So by computing resources, I don't know if anyone has watched the movie Hidden Figures, but I really like the movie. Three women who yeah helped to launch the first rocket, first American rocket. So but basically to the moon. So basically the point here is in those days, they needed big machines, huge machines to run calculations, to do computations. But today, even on your phone, on your smartphone, you can actually like run computations. If you have a laptop and access to the internet, you can access powerful computing systems through the cloud and you can run computations. You know, I used to be here like at home, and then I'll be able to access like, you know, supercomputers in my college, you know, in school, and I'll be running my simulations there. So yeah, we have more access to computing resource. There's a lot more data. You know, we have recorded so much, we have captured a lot of information. And then secondly, open source tools. You can basically train to be a machine learning engineer without paying tuition, without paying school fees, because you have access to courses that are free online. You have access to resources. People have done work, they've built machine learning models, and they've put it out there for others to build on. So this has lowered learning barriers. So it's faster for people now to learn and to advance. And then the third important thing that's really pushing the movement of, you know, artificial intelligence or machine learning or data is really the fact that machine learning touches on almost every domain of human endeavor. That's just the truth. Um, if you look at the pictures here to the right, you know, you'll see a medical doctor, artificial intelligence. I've worked on a project where we've used machine learning to sort of diagnose, you know, from to diagnose X-rays and see which ones have COVID and not. Obviously, you train a machine to do that, and it's not as if the machine has the final say, but it just gives you like a proposal so that it's easier for a doctor to assess, right? And you can like really filter data more quickly. I have a friend who who knows people who work in a fashion designing company using artificial intelligence. I mean, you could be a tailor and someone can be miles and miles apart, and you would do like a virtual fitting as a fashion designer for that person. And then not to talk of the finance industry, you know, there's so much going on in fintech, you know, that's been revolutionized by, you know, artificial intelligence. And the classical, will I say, robotics professions that we know as well, they are being driven by, you know, AI. So basically, if you think about it, machine learning, artificial intelligence, they're all touching on, you know, so many aspects of human endeavor, right? And this is not to scare us or to say, oh, our lives are going to be taken over by computers. I think that's why ethics is important, but it's really about we can leverage, you know, these advancements and do more, you know, for the world today. So these are reasons, some of the reasons why machine learning is important today. Um, so really, what is machine learning? I've been talking about ML, AI, artificial intelligence, data, and all of that. Let's decode a few buzzwords before we go on. So, artificial intelligence, it's robots replacing humans. It's not exactly that. Obviously, there are roles today that machines, you know, have taken over. So I wouldn't say that's not the case in some ways, but then this pushes us to, you know, adapt really. So I came across this quote that sort of described machine learning and said, if it's called machine learning, then the machine should learn it and not you. And in a way, there's some truth in it, right? So I saw this picture as well online of a definition of machine learning. Basically, machines are in the classroom and they're learning things. And it's not far from the truth, to be honest, because what we're doing is we're teaching the computers, we're teaching the machines how to do tasks, right? So that certain tasks we don't have to do them, or certain tasks that for us, there might be some barriers, but because a computer is probably faster, you know, and has higher levels of precision, the computer is better suited for that. So just to give you a definition in plain English, machine learning is just teaching computers to learn from examples or from data how to perform tasks or to take a decision. So basically, it's really about teaching the computer. It's really the machine learning. That's what machine learning is in a very basic sense. Obviously, that's a basic definition, but then it's a simple way to kind of start understanding what we're talking about when we say machine learning. So, in essence, you are giving the computer examples of tasks, and they understand, oh, based on this is how this task should be done. Based on this information you've given me, this is how this task should be done. And the computer now learns how to do that. So that really is, how I tend to understand machine learning in a very simple way. Now, for someone who does programming, it might be a bit confusing because when you're doing programming, you're actually writing instructions for the computer to do. So what's the difference between traditional programming and machine learning? So if you look at the image here, so in traditional programming, what we have is we have a computer program, which is basically a set of instructions, and we have some input data, and we put those two together to the computer, and it gives us an output. But in machine learning, in a basic way, we have the inputs, we have the outputs, and what we're doing is we're trying to ask the computer to figure out the relationship between the inputs and the outputs. So let me give an example. Let's say you want your computer to find the square root of a number. What you do is in traditional programming, you give it, for example, 9, and the instruction will be a program that helps it to find square root. And you put those two into the computer, and the computer will give you the number 3. So that's sort of like traditional programming. But in machine learning, you have the number 9 and you have the output, which is 3. But basically, you're asking the computer, can you tell me what is the relationship between 9 and 3? And the computer now figures out, oh, actually, it is square root that is the relationship between the number 9 and 3. So, in a very basic way, obviously, there are different types of machine learning, there are different flavors, but then, you can try to think of it as you're giving the computer data and you're asking it to find relationships, you're asking it, to find patterns or, to learn something that would help you to take action or, do a task. So you don't exactly tell it the relationship between the data you're providing it. You're just asking it to do the heavy lifting. Obviously, we have to, write algorithms for that, but in a way, that's kind of, a way to understand the difference between traditional programming and machine learning. So hopefully, if you're going to, leave this talk today, you'll take that machine learning, is teaching computers to learn from examples how to make decisions. So we let the computers learn from our data what is going on. So the next time we give them more data, they're able to tell us what's going on, with that data. Um, Now let's try and decode or talk about a few, buzzwords that might be a bit confusing. So we have machine learning, ML for short. We have AI, artificial intelligence, and we have data science as well. These have very close relationships. They tend to overlap in many different ways. In fact, when I did an internship as a data scientist, that was about 6 years ago. Um, what I was doing then was basically machine learning, but that role had not evolved. It had not sort of appeared so much. Today, if I were to do the same internship, my title would be machine learning engineer because a lot of times, machine learning engineers and data scientists have similar like roles, but now, there's more, you know, clarity and definition in terms of the roles that machine learning engineers and data scientists do. But yeah, like I said, machine learning is just like, learning patterns or relationships. So the computers learn, from the data basically. So I'm trying to keep this very simple, but there's more to it, which I would let you discover for yourself. But if you want to understand at a very basic level what machine learning is, it's basically the computers trying to learn from the data. Now, when we talk of artificial intelligence is a broader field. So machine learning is actually a subset of artificial intelligence because with artificial intelligence, what we're saying is just we're not just teaching machines how to learn from data, we're actually trying to teach them to mimic some sort of intelligence, do for example, not just make a prediction on the weather tomorrow. Okay, if the weather tomorrow is predicted to be sunny, can they maybe you connect, some other devices and you're able to say, okay, if it's sunny, maybe turn on the air conditioning for me. So basically, it's more intelligent behavior that we're training the machines to be able to adopt. When we talk of data science, then we're actually think about it. What's science? Science is really knowledge, like studying to know. So we're studying more about the data. We're looking more into the data that we have to gain insights. And sometimes we also use this data to develop models so that we can make decisions. So data science has a lot more to do with handling the data, manipulating the data. Um, but if you want to understand, kind of overlaps, I have an image here which I hope explains it a bit better. So machine learning is a subset of artificial intelligence. Data science is a field on its own, but then there are overlaps between artificial intelligence, machine learning, and data science because there are techniques in data science that are being used in machine learning. And now, because machine learning as a field on its own is growing, there are techniques in machine learning that have found themselves into data science. So majorly in data science, you'll be looking at things like, mathematics, statistics, because you're trying to understand data, right? But these techniques also have found themselves in machine learning and artificial intelligence because we're working with data. So this is sort of, will I say, a very simple way to understand the difference between like the few buzzwords that have been thrown around a bit. Now, if we're looking at machine learning itself, there are different types of machine learning. You might have heard supervised learning, unsupervised learning, reinforcement learning, right? You might have heard other things like natural language processing. I'm sure a lot of us have used ChatGPT. You might have heard things like LLMs, so many things being thrown around. Yeah, a lot of them, are subsets of some of these learning types, while some of them are more, data science inclined. So, but basically, I think what I'm just trying to do is broadly help you see categories in terms of the finer details. You can always, yeah, do more research. And also, because the industry is growing, you might find different definitions from different things, from different people or different places. So what I'm trying to do is kind of standardize what is, generally, agreed upon. So in terms of machine learning, there are really three core types of machine learning. The first is supervised, and it's kind of what I showed when I was trying to explain the difference between traditional programming and machine learning, where you give the computer or the model the input. So you basically give it 9 and 3 and you ask it, what is the relationship? So you're giving the actual inputs and data. That's the actual inputs and outputs. So you're giving it data and you're asking it to basically, can they actually on their own? Can they, tell you what the relationship is. So it's also called labeled learning because basically you have labeled your data in a way you have said, these are inputs, these are outputs. Just try and match them for me. So if I'll give you examples for, like spam detection in our emails, so computers have been trained to understand that when you see an email that comes in with this sort of title or this sort of content, that's a spam or maybe like that's a scam. In any way, they're kind of very similar, right? So because computers have learned that when an email comes and they see, the things that they've been, trained to understand these are spams, they just classify those as spam, right? Or in disease diagnosis, like I explained earlier, where you have x-rays of, for example, say people who do not have a certain maybe chest infection and people who have a chest infection. And what the computer has learned to do is that it has understood the features of X-rays that, characterize chest infections and X-rays that characterize like no chest infections. So it's able to, whenever you give it like, maybe a new data from someone who has just done an X-ray, it's able to look at the features of the X-ray and decide, oh, this is chest infection, or no, this is not chest infection based on what I've learned. Then there's unsupervised learning. In this case, you don't give it inputs and outputs. You just give the computer a set of data and you're asking it, tell me what patterns can you find? Group these data sets. Just what can you start telling it to match X-ray, for example, X-rays or just some pictures. Can you organize this for me? And then the computer would see a lot of pictures that have a certain feature and categorize that in one class, and another, set of pictures that have another feature and categorize them in one class. So if you look at your phone, for example, and sometimes, you look at a picture and then, your computer is able to detect a face. And then if you scroll down, sometimes it gives you more pictures that has that face. It's been able to see, oh, okay, let me look at this face and let me see, are there other groups, like that look like this? It's just it can really be able to organize data in groups based on like common features that some of the data sets have. And then the last one is reinforcement learning. And this one is, very closely linked to artificial intelligence. So when we look at things like self-driving cars, for example, they learn, through a reward-based or an agent-based learning. So what that means is the computer, you're not giving it like, instructions. You're just telling it, I put you here just to learn based on your environment. Imagine, for example, you have a set of people, they're thrown into a room, but that room is a maze, and you're telling them, figure your wall, and we know that this is not the road. They take another, turn. So basically, they have to learn from their environment or learn from rewards or penalties. They take an action, and then if there's a reward, they know that, oh, this is the right action to take. But if there's a penalty, they realize, no, that's not a good strategy. So, like, for example, self-driving cars, like if they beat the traffic light, there's probably a penalty. Robots, if they do something wrong, there's a penalty. So basically, in a way, they're learning a strategy from their environment. Um, if it helps, here is a little cartoon of supervised, unsupervised, and reinforcement learning. So basically, those are the three core learning types. I know I've breezed through this, but yeah, I hope that you kind of are starting to get a sense of the fact that there are different kinds of ways we apply machine learning based on like, the problems we're trying to solve and what we're trying to achieve. Um, I'm not going to talk too much on, the workflow in practice, but I wanted to highlight, something just to show you, how it works, in terms of give you a high level understanding of what you will be doing as a machine learning engineer. So this is actually one of the first projects I worked on in industry. And I think why I'm showing this is really to highlight to you that, it's not just about writing code. It's not just about building a model. There are things that happen to altogether make, it more practical and make it like a seamless workflow. Sometimes you don't have data. You have to figure out how to collect data from, different kinds of places. It could be from online databases. It could be from a library. It could be from an archive. It could be, you have to read papers or publications. You have to start by collecting, data. Obviously, you have to also think about your problem. So here I'm just kind of presenting the workflow in practice when you have a problem or machine learning, solution that you're trying to build. But yeah, you also have to think about, the problem and the steps. But essentially, as a machine learning engineer, if you were working on a project, you think about how you would collect your data. You think about how you profile your data. That's really just exploring the data. Because when you collect your data, you put it in, somewhere called a data warehouse. Now, it's not a physical warehouse where we go and dump things is just like a soft, it could be a software on your computer, right, where you just store all your data. And then in this place, you can actually just explore your data just to understand and start thinking about which ones you don't need. Because at this point, you're really kind of collecting a lot of things. And then when you get to the profiling, you're really trying to decide which ones you need, which ones you don't need, which ones are good, which ones are not good quality data. Um, so in this project, I just used the software. It's called ArcGIS. If you're like a, you know, geospatial analyst, or you've done, any of those, like, working with maps and rasters, you probably know about the software. But it's just, somewhere you can house your data. And then after that, you have to do more digging into the data. Someone said machine learning is, well, early on, 80% more data and 20%, just like the algorithms. And I mean, I don't totally agree, because now machine learning is changing. There are a lot of things involved, like when you come to monitoring your models. But then I think what that message is that your data goes a long way, because it's a computer, so it's garbage in and garbage out, really. So you have to make sure that, you don't ignore your data quality. So basically here you're processing your data, you're trying to see, okay, how do I change my data to give my model more information? Do I need to do some things like maybe normalize? Because now what that means is, some data, they have more magnitude than others. Let's say, for example, you're working on a model to predict house prices in your area. It's a very common machine learning tutorial model, and if you look at something like let's say one of the things you're using to predict is, let's say, the number of rooms. Number of rooms typically will be in, units. It's like two, four, five, six. But if you're looking at, let's say, square feet, those are like in thousands. So if you don't do any transformations or any processing to that data, the model will think, oh, the things in thousands are more important than the things in tens, because of just the magnitude or the values. So we have to think about things like that in the pre-processing. And then here is really where we code up the algorithm and we decide what we want to use. What sort of machine learning model do we want to use? And then after we've trained the machine to be able to do whatever we want it to do, we can now deploy. Deploy just means send it into production so people can use it. And we now have to think about how we monitor this. So I did this project for being able to predict heat across the globe. I'm not going to start talking too much about that, because that's not the point. But the point is really, you have to go through a flow, right, as a machine learning engineer working on a project. And this is just to give you a sense of how the flow looks like. You start out with your data, profiling, collecting it, profiling it, processing, modeling, and then you go on to deploy and monitor your model. Yeah, so basically it's just to give an example of machine learning in practice. Um, yeah, I hope I'm not going to run out of time, but now I want to talk about the roles and skills in the machine learning space. So if you're thinking about yourself, where can you fit in? You're thinking about, like, where can my skills go in? Or really, I mean, how do I even know which skills to like build if I want to go into machine learning? So engineer. So this is actually one of the first projects I worked on in industry. And I think why I'm showing this is really to highlight to you that, it's not just about writing code. It's not just about building a model. There are things that happen to altogether make, it more practical and make it like a seamless workflow. That's what we're going to talk about now. I'll just start by, showing you a few common roles in the machine learning space. So the first one, obviously, is a machine learning engineer or a machine learning research engineer. And that has been my role while working in the industry. And basically, you're building machine learning models. So, the workflow I showed before, that's what, you'll be doing. If you're working as a machine learning research engineer, sometimes it would warrant that sort of redesign some, models, do more research and see how you can really tailor that to your own problem. that you're trying to solve. But essentially, you're building solutions, you're building machine learning solutions for whatever problems you're trying to tackle. Then data scientists. So the reason why a data scientist is here is because, like I mentioned earlier, there's a lot of overlap between the two roles. And to be honest, in some companies, they call machine learning engineer data scientist, and they call a data scientist a machine learning engineer. So there are techniques that, both data science and machine learning engineers would use. But sometimes, if you're working as a data scientist, you would need to know a lot more about data handling, like how to work with databases like SQL and things like that. So you need to know a bit of data engineering as well as a data scientist. But yeah, the roles are very similar. Then there's machine learning platform engineer or machine learning ops. So basically, if we go back to the workflow here. A machine learning platform engineer or someone who's working in machine learning ops would have more skills in deployment and monitoring. So you are really setting up the infrastructure, for the models to work, right? Like for the models to be sustained, apart from just building it, because it's one thing to build something, is another thing to put it into production so people can actually use it. And is another thing to ensure that that thing keeps working after some time. So a machine learning platform engineer will set up that infrastructure. Then we have product roles with ML focus. So like a product manager, with machine learning focus. So as a product manager, you're trying to understand like user needs, you're trying to understand the problems so that we're actually solving a problem that people would use. And generally, you're more interfacing with the business side of things. But also you have to understand, the workflow. And a lot of times it's good to have that, practice of being a machine learning engineer before then going on to take product management roles, because then you have the technical depth and you're able to guide other people. Then, as an academic or industrial researcher in machine learning, basically, you might be working in like, education, or you're trying to work on machine learning theories. You're the ones, developing the theories that people would use. And essentially, you're doing a lot more, a lot more of research and not really practical work. But you will still have to build models. You will still have to get data because you're conducting experiments basically, in machine learning. So you will still have to go through the workflow in a way. And then an applied machine learning engineer. So an applied machine learning engineer would be one who would take like a machine learning solution or machine learning theory and sort of apply it to like technological use. So like there's an algorithm, for example, or machine learning model that has been developed for organizing photos, or maybe just a machine learning algorithm that's been developed for grouping data. And then an applied ML engineer would take that and yeah, be able to build that feature into a phone so that it can organize photos. So basically, you are bridging research and industry. That's your task as an applied ML engineer. And then we have an AI ethics specialist. Ethics is becoming a really important part of, machine learning, artificial intelligence, because there's a lot around there. Those are like concerns that people have, which are very genuine and valid. I mean, even I have concerns on using some of the models, but I think the thing is, if we're able to put safeguards, it makes it better and like, safer and more secure for it to be used. So an AI ethics specialist, someone who is very important as well. And if you don't have, machine learning, understanding, you won't really know how, machines can fall short where, for example, they have bias and there are issues with fairness. So these are some common roles in the machine learning space, but ideally, all of them require some sort of skills, right? And if I were to give you like a basic skill stack for machine learning, this would be it. Here there are like five core areas. The first one is your math basics, right? I mentioned at some point that I'm currently relearning and upskilling, and I'm going through like my, undergraduate math textbooks. And basically machine learning, those models that help the computer to learn are built on math. They're built on things like algebra, to be honest, like linear algebra, statistics, calculus, differentiation. So they're really found at the foundation of it, mathematics is involved. So if you're someone from a pure, like, math background or physics background, and you're wondering, I mean, I don't even do coding, I think you can build on that because at the very basics, there's linear algebra and people with sort of like pure science backgrounds can thrive in the research, arm of the machine learning space. Then programming. So for machine learning, the most commonly used programming language is Python. Sometimes people use R for like statistical models, but then Python is the most common one. There are other ones, people use Java, but those are, I think, more niche. Most people, use Python. Then there's skills you need for actually, the workflow, like practical building of the models. You need to understand the algorithms themselves. You need to understand how to evaluate them, how to assess them. Because one thing is to build a model, but how do you know it's working right? How do you know it's, not throwing you, it's not giving you wrong predictions? You have to be able to, like evaluate them. And then tuning is like a machine learning term, but in essence, improving your model. That's what it means because there's sometimes you build a model, but then you can improve it, right? You can make it better. So those are like practical aspects of, model building. And then data engineering and tooling. So learning roles have evolved to actually include a bit of software engineering, where people where machine learning engineers actually need to build software infrastructure. So you actually need to build systems that, will help your machine learning algorithms to seamlessly work so people can use them, right? So basically you need some sort of ex- experience, no, I wouldn't call it experience, I'll say knowledge or skill in handling data and building machine learning pipelines. So pipelines, if you think about it, pipeline enables a flow, right? So how can people, use your models in a way that there's a flow? For example, if I want a machine learning model, that helps me maybe predict what to do based on the weather tomorrow. What I have to do is I have to upload data about my weather to the model, and then it processes it, and then it gives me back that um, output. So basically, there's a workflow, right? Some of the apps that we use, they're based on machine learning, but then there's infrastructure there's systems that have been set up to make sure that it's a smooth flow, or else I can't imagine if I want to use my phone, let's say like to organize my photos, I'll have to go to one app that helps me to extract all the pictures I have. I have to go to another app that then I have to list all the names of people that I've ever taken pictures of, and I have to go to another app. Like basically, things will be segmented. So machine learning engineering and tooling and, like pipeline infrastructure in a way just enables efficiency of the system. And that's very important, really. And then communication and ethics, because now people don't see machine learning as just a black box. You can actually, interpret or explain, the thinking of the model, and that makes your work, more credible and more transparent. So, that's also a skill a machine learning engineer needs to have. And you have to also learn how to document because when you're building models, you can have like version one, two, three, up to I don't even know. So you have to have skills of documenting, controlling your versions, and ensuring a lot of things around like ethics and communication and documentation. So at a glance, this is probably, what I would say is the stack of skills that you will need, as a machine learning engineer. Um, Now, this is just really to talk about like what you would, need to go into like practicing. But there are also specializations in machine learning, which today they are becoming their own broad fields. So if we look at things like natural language processing, right, those deal with like the language models that we have. So the chat GPTs, and all of them, the birds and all of them. So that's one field that sometimes people would rather specialize in. There's computer vision, which looks at a lot of image processing. Okay, so natural language is more like text, computer vision is more like image processing. There's time series forecasting, which looks at data that is sequential. So, for example, if you collect, let's say, like financial data every hour, that's like, sequential data. We have recommender systems, YouTube, what the algorithms are doing. That's another field on its own. We have machine learning ops and deployment. So that was what I was talking about, like monitoring and sort of setting up infrastructure. And then we also have the machine learning research or theory. So these are some specializations that you can choose to go into that's after having like a kind of basic skill stack. Now, one thing I want to highlight is these are not things that, you have to be an expert in before you move on to specialization. These are things, though, that you have to have in your foundation, because if your foundation is not strong, then going on to advanced things, would be a struggle in a lot of cases. But I'll just put this a bit more into perspective. I don't know if you've heard about the T-shaped professional model, but basically, what this means is as a professional working in the tech industry, I think a lot of times people use this model. There are a broad range of skills that you're expected to have. And then, aside that, you can have deep skills or, expertise in a certain area. So a T-shaped, professional or a T-shaped machine learning professional would have this in their skill stack, right? They would basically have this covered as foundational knowledge or working knowledge. And then they would now have deep expertise in one of these areas. It doesn't have to be one, these are just some. There are, so many more. But normally, you would have expertise in a certain area. So kind of this is just a way to just put together, like what I've shown about the skills that you would need as a machine learning engineer in the industry. You need a broad range of skills, which are some of the things. So you can think about this is your math basic, this is probably your programming, this is your data tooling, this is your communication and ethics, just a, a broad range of, tools. So these are like generalists for machine learning engineers, generalists like skills. And then this is like deep expertise in one. So it's called a T-shaped model. But to be honest, nothing stops you from being a comb-shaped model. So what that means is you don't just have to have one area of deep expertise. You can have multiple areas of deep expertise. But that comes, with time, right? So I think it's usually it's usually better to start off just having the broad knowledge and one deep expertise, and then you can now sort of develop over time, right? So I think I had to mention this so that it's not set in stone that you just need one area of expertise. I think the point here is, you know, you should have at least one area where, you stand out for, like people would know you for, but nothing stops you from doing more. So let's look at a roadmap. Lydia, I'm not sure how much time we have, but I'll try to breeze through this because a lot of all of the, like the roadmap depends on, so many things. It depends on how much time you have. It depends on really how far you want to go into machine learning. If you just want to know what's going on, you're not even really looking for a job in the area, that's fine. If you just want to know because, I mean, maybe at some point you're thinking of, then yours might not be a 6 to 12 month roadmap. It could be longer or shorter. So I think this is just kind of what I would suggest if you're looking to go into machine learning. And the truth is, it's not something that happens overnight. Like I shared in my own roadmap, like it took some time, right? Especially if you're not coming from a background where you've been doing a lot of coding or you've been exposed to a lot of programming or data science or math or things like that, it might take you some time, but let's look at a roadmap to help start, your journey. The first phase I'll say is about laying the foundation. So it's really important to have a strong foundation. And a few things you have to do in the phase where you're laying your foundation is to get your coding basics and your math reviews. So the skill stack, I talked about some math basics, to look at linear algebra, probability and statistics, calculus of optimization. So those are really things you need to, get together. And you can take a machine learning course to help you with that. So during your first phase, you can think about sitting down with a machine learning course to really help you get, to grips of this. Obviously, I haven't seen a one size fits all course, but there are many that would help you. And then the rest of it now depends on where your interests or commitments or capabilities, would direct you. But one thing I would say is it's better to in this phase, make sure that you are actively learning. You're not just um, reading or going through the tutorials. You're actually doing, mini exercises as you go on, because these will solidify your learnings. And especially with programming, you have to make sure you're doing it. You don't learn programming just in your head for 2 months and then you come back and say, okay, I finished learning like the programming language in my head. I'm now going to come to a computer and start the actual programming. So you have to learn as you go. So you can take about 3 months to do that. And I think, depending on, to be honest, your commitments, sometimes you're working 9 to 5 or 9 to 7, and you don't have that time. You might only afford 30 minutes or 1 hour a day, and you just adapt it. This is just like a template. Is not, like a fixed rule. There's no fixed rule. It's just a suggestion looking at if you wanted to give, like, for example, a year to yourself to really go into this field. In your second phase, what I would suggest to do is to build and share. You've laid your foundation, you understand the basics, now start building and start sharing. Do actual projects, right? Write about them, ask people for feedback. There are many communities for machine learning. I mean, in fact, too many probably, but it just goes to show that there are opportunities to share what we do and seek feedback. And the more you do this, the better, because you're creating a portfolio that you're able to showcase when you're looking into actually, starting a role or looking for an opportunity in this field. Because, qualifications, certificates, yes, they matter, but really people are looking for those who build stuff and not really those who have acquired qualifications, right? So yeah, you have to show like that you've done projects. And then in the next phase, what you're doing is kind of thinking about a specialty and applying. Maybe if you're starting to think about, a role in machine learning, you're really looking at, okay, I want to specialize in this. I think I know where I want to put my energy in machine learning. It's this part, and you're diving more into that domain. And then you're you know, probably seeking research collaborations with professors. It doesn't even have to be professor. You could approach maybe someone who is, even if it's a PhD student working on that, and you ask, oh, can I help you with like certain aspects? Can I do like data manipulation, or can I build like the low level, like can I build like maybe some bits of the model? You're just really trying to learn deeply in a certain aspect, or you do an internship or boot camp or summer schools, just really something to help you like intensify your learnings and your skill set. Or sometimes you can just go decide on a project or a paper that's been published and you replicate it or you improve it or extend it or something. So really here you're honing your skills, right? And you're refining them in your chosen, field or domain. So that's kind of like how you go. But I just want to highlight a few things to take note of so you can avoid some, mistakes. So like I said earlier, first of all, it's more important to do things, do projects than to just keep on taking courses or reading or just, just qualifications, right? So it's better that way to actually build stuff. And then jumping into complex things, I know they're like exciting things sometimes. When ChatGPT came, I remember, so it's built on, kind of machine learning technique, which is called transformers. And I remember a lot of us just wanted to apply transformers to everything because ChatGPT seemed like it was doing, so good. You're building a model for yeah, maybe like simulating something different and you just want to see how you apply transformers. So, but then if there's no, basic understanding, it's gonna crumble because it's garbage in, garbage out. So yeah, just try and make sure your learning is progressive. It's very important to do that. And then don't ignore data quality and domain knowledge. So data quality, what I mean is if you think about it, we said machine learning is the machine learning from examples or data, right? So basically, whatever you show it, if you give it, if you want the machine to find the relationship between 9 and 3, which is square root, and you give the machine 9 and 4, that's, like that's what it's going to tell you. Like it's just going to figure out something for you that might not be what you want. So you have to make sure you're giving it the right data. So the quality of your data matters. And then domain knowledge. So what we mean by domain knowledge is really dependent on the problem you're trying to solve. Because depending on what you're trying to achieve, there are times when having an understanding of the, data or the problem makes it easier. Because, if I'm solving a certain problem in physics, I think physics is even too broad. Let me look for let's say I'm solving a certain problem in biology and I'm giving it some sort of information, like, from finance, which is not really related, it's going to be confused. Or if I'm solving a problem on biology and I don't even care to understand the data and what it means, if the model, the machine tells me, like, this is the relationship I have come to understand, and the machine is taking decisions, if I don't know that there are some rules that can't be broken, then I'll probably have a wrong model. If I don't know that, um, let's say, for example, I can't have negative, what do I say? What can be negative? Um, I mean, we can have negative cash flow. I mean, example of something that can't be negative. I couldn't have eaten -2 oranges, for example, right? So, basically those kind of things that are very awkward or absurd. It's just like sometimes when you give ChatGPT something to do and it comes up with a very, very weird or wrong, explanation or information, So imagine if you don't know that that is wrong, if you don't have, understanding of, the knowledge of that field, then you're just going to take it as that's right. So domain knowledge is important. And then you have to document and, communicate your results. Documentation is important because sometimes you yourself, you might want to replicate that, or people might want to reproduce what you did. And then do not neglect ethics and bias. I think this is important because, bias, especially when we have models, machine learning models that interface with human interactions, they can be biased if we use only data from a certain subset, right, of people. So yeah, you have to be careful with that when you're looking at developing your skills and your knowledge in machine learning. So I think I'm going to run through this. Yeah, so just some resources because it's very easy to drown. There's so much out there. You know how I said like, you can retrain in machine learning without essentially paying fees because there's a lot of information and there's free resources. But then at the same time, there can be information overload, right? There's a lot. So if you're just looking for somewhere to start with, I would say these are a few kind of, tools machine learning engineers would need to use. And these are really, for programming and to help you come to grips with some machine learning models. If you've ever been in the machine learning space, some of these are very, common and very basic. And I chose, some of the very basic ones because there are variations, right? But some of the very basic ones are more established. There's more documentation, there's more help. They have forums where people ask questions, and you can get answers. They have like very established documentation. So these are just examples of tools that you can use for different aspects of like machine learning. In terms of courses or where to start from, because you really wouldn't be using these tools, to be honest, if you've not gone through the rigors of, learning the courses. So I personally took Andrew Ng's machine learning course. It's on Coursera, but then now he has a website because he was really good. So many people I know have actually benefited from that course. And then he's decided to start up, his own. So sort of teaching yeah, like facility or so if you go on his website, there are a range of courses you can look at whichever one suits you, but on Coursera he has some courses that are very basic and he has a very like um easy way of explaining things. Obviously, you have to supplement your learning because another, downside to simplifying things is that, there are finer details that you also need to understand. But if you're looking for somewhere to start from, you can start from there. Google also has a machine learning crash course. This is really for going into more advanced like parts of machine learning, like deep learning. Then if you want to solidify your math, maybe there are math concepts that you come across in the course and you want to know more about. I use Khan Academy or Three Blue, One Brown, like they're very visual and intuitive ways. For example, how do you understand linear algebra? Like as actually very intuitive ways, so that you can actually explain what's going on. You're not just cramming, oh, this is the formula, but what is actually going on? What are these transformations? What do they mean? And then to practice coding, we use Python. You can download Python on your laptop, it's free. But then you can also use Google Colab and Kaggle Learn. Like personally, I use Google Colab a lot because I can access it from anywhere I go. But yeah, there are limitations, and sometimes you have to download Python on your own laptop. But if you're looking to just start, you can just go to Google Colab if you have a Google account. And then when you come to preparing for your own interviews, if you're looking for a job in this space, there are a lot of resources, to be honest. But this is a book, on especially machine learning interviews, but it also depends on the company, what their job description is, what they're looking for, or what you are looking for as well. So this is just a snapshot of resources. Another thing I also wanted to touch on is, you know, okay, we're talking about you going into machine learning, you building, you sharing. How are you meant to sort of, develop machine learning solutions that you can showcase to other people? You can start by solving your own problem. Do you have a problem that you can think about using machine learning to solve? I mean, because a lot of people who have developed apps, right, they've used machine learning to solve. One of the problems that I'm actually thinking of is I want to teach my daughter how to speak Hausa. But, maybe if someone is interested, they can work on it because I don't even think I'll have the time. I want to teach my daughter how to speak Hausa, but then I find that a lot of the, books or, shows that we have, they are in English, right? So can we have a machine learning model that, integrates, translating, there are like, AI translators, language translators that would just on the fly, real time, be translating, those English shows to actually Hausa, because there are some that, I mean, I guess there are a few, like maybe kids learning educational shows in Hausa, but some of the ones that, you probably would want are in English. And do you want to, yeah, how would you can't sit there and be interpreting everything, but on the fly, can we just have a translator that just translates, real time? So that's I think one very interesting problem. In fact, I think someone has probably even done it, to be honest, because this world, there's so many, like sometimes you think you're thinking of a problem that's not been solved, but yeah, probably someone is working on it. So yeah, you can think of your own problems and how you can solve them with machine learning. You can explore data sets like, with fresh eyes, there are data sets that you can maybe interpret them in a different way, design a dashboard, machine learning model, and then integrate like a dashboard that presents it differently so that people are able to understand what's going on better. Like I mentioned earlier, you can extend, a paper or publication or project, or you can, if there's a model that has been built, but then maybe it's not really in production, it's just there as a code. Oh, can you actually do like an end-to-end project and integrate it so that it's it actually has like a cool user interface that people can use. Can you do something for a community you care about? Can you volunteer to do something, machine, like develop a machine learning, solution for something you care about? It could be, like a humanitarian um yeah, project about something close to your heart, because sometimes motivation comes a lot when you're doing something, that you really care about. Or can you just, like think of how you can, if you love teaching, how you can create educational or explainable like tools, yeah, like solutions for people. So I think the idea I was actually talking about is probably related even to the educational, like, tools. So yeah, like these are ways to think about projects, like in machine learning that you can, yeah, think of. Here I have a basic canvas that you can use when you actually have a problem in machine learning that you want to solve. What are the things you need to have on ground to be able to help you achieve these? So, you have the problem, what data do you need? How are you going to evaluate the model, like how well it's doing? Who are the people that need this, or who are the people that you need to help you on this project? What sort of machine learning technique are you going to use? What algorithm are you going to use? Okay, what's the output going to be? Is it going to be a software, or is it going to be like a dashboard? Like, what is it going to be? And have you considered the ethics and the impact of your model? So basically, you can think around these things as you yeah, go on a project or build a solution, for using a machine um, learning approach. Um, I'm just going to briefly highlight a few ways you can get experience, if you're looking into getting into the machine learning space. Because, sometimes we say companies are looking for years of experience or certain experience. How do you get experience without a job? Or how do you get experience without experience? But there are other ways. And to be honest, like I said earlier, in tech, people are looking a lot more for, someone who can build, right? So if you can show you've built, or you can build, I think it's a strong selling point for you. So a few ways you can get experience without a job. You can join communities where you're actively contributing or you're engaging in competitions. There's a platform called Kaggle. They do competitions, and like like they also have prizes to be won, but they have leaderboards as well, which could count. These are things that you could showcase. There are other platforms or communities that you could join, and, like if you actively, contribute, you can go up the ranks. But then, your priority is not just about the ranks. Your priority is also to get the experience and the learning. You can contribute to open source projects on Git. There are people who want contributions to like projects that they open up to the public. You can decide to work with academics. Sometimes, you can go on LinkedIn, or you can go on schools, their profiles, and just offer like, oh, I have a bit of experience in machine. I've done this course and I'm building these solutions, and I would like to offer some help. You never know. You can volunteer, and then there are summer schools, or I think nowadays there are winter schools and autumn schools, or maybe spring schools, I don't know. But there are those kind of opportunities with long programs where you actually get to yeah, you actually get some experience, right? And then you can teach what you're learning. You can start by teaching a group of people who don't really know about machine learning, and you want to share with them what you have learned. But if you really want to get a job, these are four things that I think you should have under your belt. Your T-shaped profile should be sorted. You should have a breadth across the skill sets that I highlighted, and one deep spike. I think the one deep spike would now depend on the company, because there are companies who are looking for people with specific roles. So, but I think the priority is really on the breadth of the skills, because the deep spike can be developed over time. And then, targeted applications and referrals, yeah, like there are opportunities out there. There are people who are, remotely working. So these are also options. Can you get a referral? Can you ask people for a referral, which is also one way that could work. But also, you have to make sure you have a portfolio to showcase what you've done. It's not just about I know the buzzwords, or I have a lot of buzzwords on my CV. can you actually demonstrate? Do you have like, an account on GitHub, or do you have a blog post where a blog where you've posted like, your projects and people can really see the impact that you're, having. And in terms of preparing for your interviews, there are really three major interview steps. There's the coding, where they generally check your coding levels. There's ML for the machine learning fundamentals, like, the skill sets that we talked about. And then there's system design. System design is just talking about you being able to think about how to implement a project from beginning to end. How do you walk through like all the infrastructure, all the things that you really need to bring to life that project. And then we're not going to forget the behavioral or the soft skills. So those are also aspects of, the interview that you will have to think about. Um, I'm gonna have to talk a little about ethics because that's important, but I'm just going to use this sort of image to talk about it. So ethics in AI is important because there's issues about around privacy. You personally, I don't like my data being used to train models except if I choose to give it out. So you have to make sure you're sourcing data in an ethical way. And then your models need to be like trustworthy. You need to prove to people that I built this model to be robust. It's not gonna give you wrong answers because I've tested it thoroughly, right? And then your models, are they preventing harm? Are they spinning out fake news? If they have the potential to do that, how are you putting barriers? Like, how are you going to like prevent that from happening? And then transparency, there are many things people could do to show that a model is correct, even if it's not, but that's not the right thing to do. We want to be transparent. Then fairness, I think this one really hits hard because if you think about it, there are models that have been trained on certain data, people in a part of the world, and then they're being applied for people in another part of the world, but there are differences in culture, in, work styles, and so many things. So you have to make sure that your data is fair. There's no bias in your data set. And then accountability, are you actually heeding to, the protocols, the rules of the industry and yeah, maybe the business. So yeah, basically you have to keep, you know, in mind ethics when you're building machine learning models because we don't want our models to be causing harm. I remember what's his name? He got the Nobel Prize for this year for physics. I just lost the name, but he worked at Google for a while and he's the father of, like AI. They call him the godfather actually of AI. And he resigned from his job at Google, saying that, um, what some of the AI models are capable of doing. He's scared of it, you know. But I mean, I think yes, we can put checks in place, right? We can do our best to put checks in place when we are, generating machine learning models. And the truth is, technology on its own can be used for good and it can be used for bad as well. So, but we can prevent the use for bad by the way we develop our technology. Finally, as I come to the end, I'll just say, as you keep learning, it doesn't stop. There are ways to stay current and keep your learning. You can subscribe to some newsletters or podcasts, just a few. You don't have to subscribe to all. Just pick like two or three newsletters that, can be dropping in your emails to help you know what's going on in the industry, the models, or how people are solving some of the problems that are in the industry. You can also read papers, one paper a week. There are papers that come with codes that you can even try. And then you can also go on learning sprints where you set clear goals for yourself. For the next 2 weeks, I want to do this in machine learning. I think sometimes setting, short goals and working this in the software industry. So if you start doing this, it's something you're going to go on to use in yeah, in the industry as well. So finally, in I just want to leave you with something to help you start off if you're really looking forward to going into the machine learning space. Just, you can curate a 30-day action plan for yourself. I plan on sharing the resources, like expanded versions of these resources, because I know there might be people who want to like take notes of some of these resources, but I'm hoping to curate like a more detailed handout that for those who really want to go into this space um can use as a pointer. It's just really a template. It's not nothing set in stone. It's just a guide. But on your own, you can really just think about for the next 30 days. If you want to go into this space, what challenge will you give yourself? It could be to read, or to listen to a podcast once a week for the next, no, not once a day for the next 30 weeks. It could be 5 minutes, 10 minutes, you can select two or three podcasts and you listen to them 10 minutes or 5 minutes every day. Um, but then you can think of also a project idea. What idea do you think, you can solve with machine learning? And then I think it's important to understand that sometimes it's not easy to do these things alone. Is there someone who can keep you accountable, someone who can push you? Is there someone who you can also push because then you can help each other? And at the end of the day, what will you probably give yourself as a reward? Maybe that will be a motivation for you to actually challenge yourself to do something. So yeah, you can, write up your goal, your idea, and maybe how you want to keep yourself accountable. So yeah, thank you very much. I have taken a long time, but I think I hope this has been worth your time. And if you have any questions, yeah, Lydia, over to you now. Thank you.
Thank you so much. We have a couple of questions in the chat. I'll just quickly ask them. So someone asked if there's a relationship between data analysis and machine learning. If yes, how do the two relate?
This. So essentially, a data scientist and a machine learning, like I've tried to explain, and machine learning engineer, they have very similar roles. If you think about it, machine learning, some algorithms use math and statistics, and you need to think about the data as well. So data science is a fundamental part of machine learning. But like a data scientist, sometimes might work a lot more on the data side, trying to understand and gain a lot of insights from the data, especially because there are business requirements to that. So a machine learning engineer, well, obviously it's important to have some sort of business acumen, I would say in a way, because at least you want to develop solutions, especially if you're working in the industry. Let me yeah, highlight that. If you're working in research, you're not really thinking much about like the business side of things. But if you're working in the industry, sometimes, as a machine learning engineer, you might have to think, oh, how does this affect the business? Not in a very like broad way, just, probably in passing, to be honest. But as a data scientist, you also need some sort of business intelligence because what you're trying to do is to gain insights from the data, more or less to help the business. So on this chart here, I mean, we can see how machine learning, data science, data engineering, data analytics, how they interact, right? So data analytics, I mean, that's another terminology. But then, you do a lot more of like math and statistics. You're just studying the data, doing a lot more data wrangling, data visualizations, data manipulations. You're not really doing machine learning. Like you're not trying to, teach computers from examples how to learn to perform a task. You're more understanding your data, preparing your data. So a data scientist also would have some sort of data engineering skills, especially things like SQL, because then you're managing databases. You're trying to prepare the data, you're trying to source the data. So that's kind of where basically data engineering would come into data scientist role. So there are overlaps because yeah, as you can see, a data engineer also does programming. A data engineer does like a lot more SQL. You're really trying to set up the pipeline, like you're mainly concerned about data. So in a very basic way, the roles that have the data in the titles, they're more data related. While a machine learning engineer is really more trying to teach the computer how to learn to perform a task. So in a very basic way, I would say, this is kind of a very simple chart, to understand the requirements or like how the roles play out. So I
Oh,
don't know if that has answered the question.
I
I'm
think
trying
it
to look at
did.
the questions that we
I
have
think you
actually.
killed three birds with one stone. I think the data analysis and data
Okay.
engineer and the SQL, I think you touched on all of them. Yes, thank you very much. Someone asked a question in relation to business. How can AI ease
Mhm.
tasks, outsourcing, and delegation for small business owners as a cost-effective tool?
Okay. I think what you're asking me to do is, yeah, tell you. I think from what I see is I should tell you an example of how I can use AI in my small business, right, to reduce cost. I think that's how I would paraphrase the question, and I hope that is what is in your mind. And I think that's a question that depends on so many things. It depends on the business, to be honest, because depending on, the business you're running, you can automate certain aspects of your business.
Mm,
And that's what a lot of companies and a lot of fields are doing today. I mean, it almost feels like, everyone's just padding ChatGPT to the software that they are providing, because ChatGPT can do so much now, it can, will I say, give you information that
mm,
you have to spend hours searching for. So you can
mm,
leverage, right? In terms of task outsourcing and delegation,
mhm,
um, you can think of things like tasks that are mundane or that are repetitive, because
mm,
those are, kind of tasks that computers can shine in, because shine if it's repetitive, if it's, something that is just on and on and on, like maybe populating a table with data, you can build an infrastructure that when that data comes in, it's simply automated to populate, and then given that data, it can sort of maybe give you insights on decisions to take for your business. So I think if you have a specific maybe business, maybe it's something to brainstorm on, how can AI help to automate certain processes, especially processes that are repetitive or that are, like that just involve yeah, time consuming tasks that are mundane, and you can just, simplify and speed up using AI.
mm,
And that can reduce your cost,
mm.
because if you think of, you put in so much time to, to maybe gain insight from your data, why can't you just use AI? You feed it your data, it's just, understands the relationships and the patterns, and it, gives you information that would now inform your business. So maybe if you have an example, you can give us an example of a business, and all of us will help you brainstorm on how specifically AI can. But I think it's really about automating like repetitive tasks, really.
Yes, thank you. I think the person that asked is not on, but I think they'll watch the replay. And I mean, I stand corrected, but I think some customer service use AI, right? Before you actually talk to a person, it would say, oh, you've reached this business XYZ. If this is your problem, press one, press two, so that before you actually talk to somebody, you really need to talk to that person. So maybe cutting hours that somebody is spending on the phone and maybe the queuing system, right? Yeah.
Yeah, yeah, no, that's true. So, yeah, that's another way, like customer service as well. Yeah, even like things like recommender algorithms,
Mm,
that instead of you spending so much time on a website, like looking for things, sometimes, the algorithms can recommend. So, yeah, people know that, oh, okay, it's fast for me to browse on this website. So there are actually a lot of, yeah, ways we can. Yeah, it's the world is your oyster. That's what I'll say.
yeah. It just gave me after this, I'm going to shut up. It gave me an idea to, I saw somebody mention something on Twitter that they'd been patronizing a business regularly, a food business, I think, for a period of time, and they stopped and nobody said anything. And people started responding with Duolingo that after like starting to learn a language and you go off and you come back, the funny response is like, I can't believe it, like you're back or something. And then I'm just like, okay, this is a free business idea. Like somebody can just maybe train a model. I don't know if it's exactly ML or AI or both, and see that, okay, this is our customers, maybe their frequency of maybe purchase. And if there is silence after a certain period of time, just let them know that you are thinking of them. And then that way, customer retention, because sometimes you get customers and then if you don't retain them, and yeah, so I don't know if people are looking for ideas for business, that could be it, but yeah, Habib, you're raising your hand.
Morning, good afternoon, everyone. Thank you so much, Dr. Zainab. It was really, really an insightful session. So I have a question. My question is, for some people that are, not maybe engineering, that does not have engineering background, science background, that are not really, they've not really done core mathematics. Some of them might be a little bit skeptical because, you need to learn some mathematics. What would be your advice for this kind of people? Thank you.
Yeah, so well, I know someone who studied as a medical doctor and went into software engineering.
Wow.
So maybe medical, you can say that's still a science field. But I think it's down to your motivation and your commitment. Um, because personally, I didn't think I'll be doing machine learning, right? So yes, I have a background in engineering, but it wasn't until 2 months before I started my PhD that I really started coding in Python. All the while, I had never coded in Python, right? So I think what I would say is it might be a steep learning curve. That's the first thing to accept. But is something that if you really sit down to think about how you want to approach it, if you really have the motivation and you're committed to going in the field, then you can always start from somewhere. Sometimes when I have like to learn, concepts that are probably like so much out of my comfort zone, what I try to do is I try to get like a working practical experience, which is like, high level, just broadly, and then I can start narrowing down in. So, in a way, for example, you can start to think of, okay, if I want to go into machine learning, perhaps the math is a huge barrier for you. Can you start by looking at these general algorithms? How do they really work in a very simplified way? And to be honest, nowadays, people have done a lot of work to break down concepts and explain them in very relatable ways. So if you want to understand something like linear algebra, you can go online and you can type in Google a very simple way to understand linear algebra. You'll find YouTube videos. Personally, I like 3 blue, 1 brown for that because they make it very easy. They make it intuitive. So it's not really about if I have a math background or not. If I'm just using my mind to actually reason and think, I can understand this. So it's going to be a huge learning curve. But what I would say is there are resources there, to help break these things down. And sometimes you can start from a high level. Okay, I mean, I guess I like using Chat GPT and the language models because for a lot of people, that's kind of the best um, example of AI. How does it really work? I'm not asking about the math behind it. What is its thinking process? How was it trained to do this? You can start from a high level and then, you can start at looking at how, people just apply these things in, their own different basic ways. You don't always have to start with the math, but the truth is, the math is very important depending on where you want to go in your machine learning career. someone who wants to go in machine learning, research, and theory would need a lot of math. Probably as an product manager in ML, in machine learning, you probably don't need a lot of math, but you need to understand, like the practice, the workflow, and then sometimes to understand the models, you need the math, to be honest. So I would say you have to first of all accept that it might be a steep learning curve, or it might not be. You never know, like, how you will enjoy it if you start it. And just take the learnings one step at a time. Don't jump into too much complex stuff. And sometimes if something is very complicated, just look at it from a high level, and then you can start breaking down. And there are many resources out there for, simplifying these concepts. So you can look them up as well. You can find me on LinkedIn. I'm grateful for the opportunity to have shared with you.
Thank you. Thank you so much, guys. Can we please appreciate our speaker with lots of virtual emojis and feedback? Like, this was comprehensive and such a great pathway. Like, thank you so much. Thank you so much, Dina. We really, really appreciate you.